Today we are going to look at some divisibility rules. They're shortcuts for you to use. You don't have to remember them, but remembering them will make your life a little bit easier in math, especially when you're looking at factors and divisibility. For this, you're going to want to use journal page 14. I'm going to be explaining the details that they give you on journal page 14. So make sure you get that out so you can follow along. If you don't have the journal ready, make sure you pause this and then we'll move forward. So the first one we're going to look at is divisible by 1. This one's really simple. Any number, ever, on the entire number line is divisible by 1. And we know that because when I multiply anything by 1, it equals itself. Any number times 1 equals itself. So if you do the reverse, that number can always be divided by 1. And we get itself. Whether it's prime, composite, square, any number is going to work for this. 2 is relatively simple. You want to make sure you know your evens or odds. Any number that is even is divisible by 2. And it doesn't matter how long the number is. All you need to do is look at the last digit. If that's even, then it is divisible. If it's odd, it is not divisible. 9 is odd, so that would not be divisible by 2. If the number ends with an even number, then that would be divisible by 2. Okay, so remember with 2, if it's even, it's divisible. If it's not divisible. 3 is a little tricky. You're actually analyzing each place value as a separate digit. And it tells you to take the sum of the digits. What this means, if we take the number 348, and we want to see if it's divisible by 3, you need to separate the 3 digits, you add them up as separate numbers, and then you look at their sum. 3 plus 4 is 7, plus 8 is 15. And you analyze, is 15 divisible by 3? And I know that 15 divided by 3 equals 5. 15 is divisible by 3. So 348 is divisible by 3. So we add the digits as separate numbers. So we'll take 200, we'll take 224, we separate to add, we get a sum of 8. 8 is not divisible by 3, so 224 is not divisible by 3. 6 is relatively simple. You need to analyze 2 and you need to analyze 3. If it is divisible by 2 and it is divisible by 3, then 6 works. So for example, 332. It is even, so 2 works. So it could be divisible by 3. 6. If I add my numbers, my digits, I get a sum of 8. 8 is not divisible by 3, so it is not divisible by 6. Okay, so we're analyzing 2 and 3. If 2 and 3 both work, then 6 is divisible as well. The next one is 9. 9 is exactly the same as 3, except we want to see if the digits add to 9. So I separate my numbers and add them up. 4 plus 3 plus 7 equals 14. That is not divisible by 9. So we'll take another example. 567. I separate my digits. I add them up. 5 plus 6 is 11, plus 7 is 18. And we can do 18 divided by 9. So 567 is divisible by 9. So again, it's the same as 3, except you're dividing it by 9. Divisible by 5, if the number ends in 5 or 0, it is divisible by 5. All of these would be examples. And we know that by counting by 5s, and we'll always land with a 5 or a 0. So for example, 27 is not divisible. 10 is relatively the same, except it's only counting by 10s. It's only numbers that end in 0. So those are our divisibility shortcuts. Now we're going to analyze two numbers, and we're going to run it through the same chart that you have on journal page 14. Okay, these are example numbers, so we're going to do them together through the video. So if you want to quiz yourself, after we get to each number along the chart, you can pause the video to test yourself. And I'll put in a slight delay so that you have time to pause it. So 678, we need to see if it's divisible by 2. What are we going to analyze? We're going to look to see if it's even. It ends in an 8, so it is divisible by 2 because 8 is even. So we know that. Divisible by 3. What are we going to do for divisible by 3? We are going to take our digits, separate them, and find the sum. 6 plus 7 is 13, plus 8 is 21. 21 is divisible by 3, so 678 is divisible by 3. So now we get to 6. How do we find if 6 is divisible into 678? We would see if 2 and 3 both work. Since 2 and 3 both work, we know that 6 works. Now we're going to look at 9. We're actually going to use the same strategy as we did for 3. I remember that 6 plus 7 plus 8 came to 21, and I need to figure out if 21 is divisible by 9. And I know that it is not. So 9 is not divisible into 678. The last two we're going to look at are 5 and 10. It ends in 8, so 5 or 10 do not work because we're looking for that 5 or 0 for the two of them. So we have our chart. 678 is divisible by 2, 3, and 6. It is not divisible by 9, 5, and 10. So next, we're going to look at 351. 351 I can see right away is odd, so I know for that it is not divisible with 2. And because I'm taking out the number 2 as one of the divisible possibilities, meaning 2 is not a factor of 351, I also know that 6 is out. Because remember that 6, we need 2 and 3 both to be divisible for it to work. So let's take a look at 3. I add my digits. That gives me a total of 9. 9 is divisible with 3, so I know 3 works. And I can also use this right now to analyze 9. 9 is divisible with 9, so again I know 351 is divisible with 9. The last two to look at are 5 and 10, and I can see that 351 does not end in a 5 or 0, which takes out the number 5, which also, if 5 doesn't work, I know 10 doesn't work. So we can see that 351 is divisible with 3 and 9. 2, 6, 5, and 10 do not work. So you're going to use this same strategy and the same sequence to complete this chart on journal page 14.